Chapter 7, Day 3. This is just a quick review warm-up where you're kind of looking at the differences between when you're adding variables and multiplying variables. So remember, when you're adding these two variables together, negative 2x's plus 5x's, that is going to give you 3x's. So you're adding those coefficients. This is different from when you're taking 3 times x and 4 times x. Now you're multiplying to get 3 times 4, 12. So 3 times 4, and then x times x, which is x squared. Question number 3, what we're looking at here, is now if you wrote this out, you're really multiplying r times r, and then you're multiplying t 3 times altogether, followed by 4 r's being multiplied with 1t. So when you get the final answer for this, notice you're multiplying r and an r and 1, 2, 3, 4 more r's. So you're multiplying a total of 4 plus 2, or r, multiplied 6 times. With your t's, what you have is you have 1, 2, 3 t's, and 1 more t gives you t to the 4th. So that's what happens when you have more complicated monomials being multiplied together. What you're really doing, I hope you're noticing, is that you're adding the 3 t's with the 1 t that's right here to get 4 t's all multiplied together. So that would be your final answer here for number 3. So this number 4 is a lot more complicated, but go ahead and see if you can try it. Pause the video and then see if you can get the correct answer. Okay, so for this one, you need to multiply the negative 2 and the 6. Remember, all of these things are just multiplied together. So negative 2 and negative 6 multiplied together is positive 12. Okay, now look at, you have 5 a's multiplied with 2 more, so you have a multiplied 7 times. And then finally you have 7 b's and 8 b's, or b to the 15th power. So those are your answers for your warm-up. And again, this is all trying to just demonstrate sort of this first idea that, remember that when the coefficient is in front, that represents repeated addition. So you're adding the same number over and over. When the coefficient is the exponent, right here, that represents repeated multiplication. So in today's work, what we're going to do is we are going to work on a power raised to a power. Something like 2x squared raised to the 3rd power. So power to a power. All right, so if you look at these expressions and you write them out, okay, you're going to start to see a pattern. And so when you take x to the 3rd right here, and you're raising it to the 2nd power, you're taking that value in the parenthesis x to the 3rd and you're multiplying it with itself twice. But x to the 3rd is just really 3 x's multiplied with 3 more, or for a total of x to the 6th. So x to the 3rd raised to the 2nd power is x to the 6th. And again, you see the second one worked out where you have a to the 4th raised to the 2nd power. Again, that's that base right there multiplied with itself twice. That's your exponent right there telling you how many times to multiply it. Well, that's 4 a's multiplied with 4 more, so you get a to the 8th. And you can see the last one is y to the 5th raised to the 3rd power becomes y to the 5th times y to the 5th times y to the 5th, or y to the 15th. So if we write these out, x to the 4th raised to the 3rd power would be x to the 4th times x to the 4th times x to the 4th. And so what we really have is 4, 8, 12 x's all multiplied together if we listed them all out like this. So this 3 and this 3 was 6 altogether. So this is sort of our guiding principle behind power to a power. So again, y to the 8th raised to the second power would be y to the 8th times y to the 8th, which would be 8 y's and 8 more y's, or y to the 16th power. So you might start seeing a pattern here. Okay, I'll jump down and do another one here. So you have c to the second raised to the 5th power would be c to the second multiplied with itself 5 times. So you'd have 2, 4, 6, 8, 10 c's all multiplied together. There you go. So hopefully this is starting to, you can see a pattern, okay? And I can work out the rest of those in the notes so you can try those on your own. But do you see a shortcut? And if so, please use it, because if you're writing this out, it gets to be kind of tedious because you have to write this out 5 times. But sometimes when you write it out, it helps you to understand what's going on, because you have 1, 2, 3, 4, 5 of these bases of x to the 4th, which means you have 4, 8, 12, 16, 20. So this would become x to the 20th power. So do you see a pattern here? I hope so. And if not, I'll try to demonstrate that what you're really doing is taking the 4 and you're multiplying it with the 5. So let's see if it works for this next one. B to the 8th power raised to the 9th would be b to the 8 times 9th power, or b to the 72nd power. So you'd have 72 b's there if you listed them all out, because b to the 8th, I'll use a different color here. B to the 8th is 8 b's, multiplied with b to the 8th is 8 more b's, and you're doing this, you're writing this out 9 times. How many do I have here? 1, 2, 3, 4, 5, 6, 7. I only have 7 of them. So here's 8 times and 9 times. So again, when I add 8 of these b's and 8 of these b's, remember, repeated addition is multiplication. So I am taking b to the 8 times 9th power, or b to the 72nd power. So, in general, our general rule here is that when we have x to the a power raised to the b, that becomes x to the a times b power. And we can do it with more complicated ones as well. And you can see these 3 examples. If we write them out, ab raised to the 3rd power would be ab times ab, or a times a times b times b times b, and so you get a to the 3rd, b to the 3rd. If we look at the second one, we have all of this raised to the 3rd power. So we have to take a squared b and we have to multiply it 3 times, which we did. Well, here's a squared times a squared times a squared, and that gives us 2, 4, 6. Then we take our b to the 1st, b to the 1st, b to the 1st, and gives us b to the 3rd power. And it can get a little trickier with negatives, so be careful, okay? So now, if we're taking this base right here and multiplying it 3 times, notice when we list it out, that -3 is multiplied. We have -3 times -3 times -3, which gives us negative times a negative is a positive, so that's 9. Positive 9 times -3 gives us -27. Then when we multiply x times x times x, that gives us x to the 3rd power. And then y to the 5th times y to the 5th times y to the 5th is y to the 15th power. So this is a power to a power. This is kind of an extension of multiplying monomials. We've been writing it kind of out the long way. But remember, a power to a power, we're going to multiply those exponents. So what we're really doing here in this next example is we are taking this base right here, and kind of like the distributive property, we have to take each one of those and raise it to the third power. So that means we have to take -2 and raise it to the third power, times x and raise it to the third power, times y to the third and raise it to the third power, which gives us -2 times -2 times -2, which is going to be -8. We get x times x times x, which is x to the third, and y times y to the third times y to the third. This becomes y to the third times y to the third times y to the third, or 369, or 3 times 3, y to the 9th. So this is sort of our strategies for power to a power. See if you can try, and I'll work out some of these other ones, but see if you can try number 11. So pause the video and see if you can do that. If we write it out the long way, remember it looks like 4x squared multiplied with itself twice. And the 4 times the 4 gives us 16. The x squared times the x squared gives us x to the 4th power. Or again, we multiply x to the second times x to the, or raised to the second power is x to the 2 times 2, or x to the 4th power. And then we take 4 and raise it to the second power, and 4 times 4 is 16. So this is our strategy for power to a power. Okay, I'll show you one more time on this example. I'll go down here to this example right here. And basically when you have something, notice this whole parenthesis right here is raised to the 4th power. So you have to take each of the pieces inside there and raise it to the 4th power. So that means I have to take 3 and raise it to the 4th power. I have to take x squared and raise it to the 4th power. And I have to take y to the 3rd and raise it to the 4th power, which gives me 3 to the 4th power is 81. Because 3 times 3 is 9, times 3 is 27, 27 times 3 is 81. Then we take x to the second, raised to the 4th power, we multiply. Remember, a power to a power is more powerful, so you're going to multiply the numbers, the exponents, and then y to the 12th power. All right, so here is this kind of simplified, hopefully. There is a shortcut. What is the general rule? Well, I've been showing you that. So for x to the a, y to the b, raised to the nth power, again, we're going to take and raise each of those to that power. So we're going to multiply, so x to the a times n, and y to the b times n. And if you're not sure whether you should be adding those exponents or multiplying, then go back and write it out if you can. Okay, and you'll see what you need to do. I will work out the rest of these examples for you, okay, as well, so you can try these before you move on to the homework. We're going to get our notes on this just to fill some things in and make sure you have an understanding. So, multiplying monomials. This is what we did before. When the bases are the same, so here's an x, here's an x. So when the bases are the same and you're just multiplying, what you're doing here is you are adding. You add the exponents. Because remember, this is like 3x's multiplied with 7x's. Okay, and that gives you 10x's altogether. But when you have a power to a power, it's more powerful. Now you are going to multiply, because this would be x to the third times x to the third multiplied with itself 7 times, which is 3, 6, 9, 12, 15, 18, 21. So that's why we multiply those exponents together. Multiply. So if you can just try to remember, a power of a power is more powerful. So multiply the exponents. Okay, so do you understand this? Okay? If you do, you have to be able to understand the difference between when you add and when you multiply. So, let's have you try number 1. Okay, in question number 1, there is nothing, none of the parentheses here are raised to a power. So all we're doing is multiplying all of these together. So when I multiply the 9 times the 5, I get 45. When I multiply 9 and I multiply 5. When I multiply x to the 10th right here and x to the 5th, that gives me x to the 10 plus 5, or x to the 15th. And then we have z to the 2nd times, or z to the 2nd, there's nothing to multiply that with, so that would just be z to the 2nd. And y to the 3rd, that's the same. We don't have anything to multiply that with, so that would just be y to the 3rd. So that would be our final answer. Now, again, if you look at this next question, give it a try. What you should first look for is, do you have any exponents? Because like order of operations, exponents come first. Simplify the parenthesis, yes, but there's nothing inside the parenthesis to simplify at this point. So now, since there's no power to a power, again, all of these pieces are just multiplied together. So I'm going to multiply the -3 and the 6 together to get -18. I am going to multiply the a squared right here with the a to the 1st. And remember, I'm adding those exponents, so that's going to give me a to the 3rd, 3 a's. Now take a look at b. Okay, you have b to the 1st power right here with b to the -4. Oh, shoot, we have those negative exponents. They're supposed to go on the bottom, but here's the thing. We're going to add those together first. And 1 plus -3 is going to give me b to the -3. And then finally, I just have that leftover c, which gets added or subtracted with nothing. So there's my answer, but remember, my final answer cannot have negative exponents. So remember, when those exponents are negative, these are going to go on the opposite side of the fraction and become positive. So my answer for this question would be -18, a to the 3rd c, all over b to the 3rd. So there is your answer to number 2. And last but not least, we have number 3. So we are taking this right here, and we are raising all of that to the 2nd power. And if you feel more comfortable, you can start writing it out. That means -8c to the 5th multiplied with itself, that same base, twice. So you get -8 times -8 when you're multiplying this together, and that gives you +64. C to the 5th times c to the 5th. Again, you have the same base. That's going to give you c to the 10th. Or again, we can look at this as taking this to the 2nd power and this to the 2nd power, which would equal -8 raised to the 2nd power times c to the 5th raised to the 2nd power, which is 64 c to the 10th as well. Okay, so that's the end of the video. Again, check the notes for the ones that you tried on your own. This is the end of day 3.